right, I'm going to do another example with using implicit differentiation, and I'm getting this problem from the homework that was assigned from 3-2, and I'm going to do number 26, which says, the line that is normal to the curve x squared plus 2xy minus 3y squared equals 0 at 5, 5 intersects the curve at what other point? So this is asking, when is the line, not the tangent line, but the normal line to this curve at 5, 5, where does it hit this curve at a different point than the point of tangency, the point of where the normal hits? So the first thing I have to do is find the normal line, okay? So I've got a piece of paper here where I've got the problem written out. And so first thing I have to do is find the tangent line slope so I can find the normal slope. So taking the derivative here, implicitly, I'm going to take the derivative of x squared, that's 2x, plus I'm going to use the product rule here where 2x is my first and y is my second. So it will be first d second, so 2x dy dx, plus second, which is y, times the derivative of the first of 2x, which is 2, minus 3y, I'm going to try again, 6y dy dx equals 0. And I'm going to solve for dy dx now by factoring it out of this term here, which would be 2x minus 6y equals, and moving the negative 2x over, or the 2x over to the other side makes it negative, and then minus 2y over here, moving it over makes it negative, and dy dx is equal to negative 2x minus 2y all over 2x minus 6y, and since all of these are divisible by 2, I can actually reduce this to negative x minus y over x minus 3y. And all I did was divide everything by 2. All right, so there's my derivative. And I want to find out what the slope is at 5, 5. So I'm going to take my derivative here, negative x, negative y, over x minus 3y. And I'm going to use my such that bar and say x equals 5 and y equals 5. And we're going to substitute those in. So I'm going to get it's equal to negative 5 minus 5 over 5 minus 15, which gives me negative 10 over negative 10, which is 1. So the tangent line at 5, 5 has a slope of 1, which means the normal line, or the normal slope, to curve at 5, 5 will be negative 1 because it's the opposite reciprocal. And so the normal line at this point is going to be y minus 5 equals the normal slope, which is negative 1, times x minus 5. And if I solve for y here, which I don't ordinarily want us to do, but I'm going to use some substitution to figure out where these two curves intersect. So I'm going to solve for y. So this is going to be y equals negative x plus 5 plus 5 when I add this to the other side. So I'm going to get y equals negative x plus 10. Okay, so two things have to be true now. I have to be on the normal line. The point that I'm finding has to be on the normal line and on this curve. And I already know one point of intersection between this curve and the normal line, but I'm on the hunt for another one. So I have x squared plus 2xy minus 3y squared equals 0. So I have a system here, and I'm going to use substitution to solve it. So here it goes. So I'm going to take x squared plus 2x, and I'm going to put where I see y, I'm going to put this negative x plus 10. Negative x plus 10 minus 3 times negative x plus 10 quantity squared equals 0. And I'm going to do this algebra here and get x squared plus, or minus, I'm sorry, it'll be minus because I have a negative x here, minus 2x squared plus 20x minus 3 times, and I have to expand this. So when I expand this, I'm going to get negative x plus 10 times negative x plus 10. I'll use this as my little area here. So negative x times negative x is a positive x squared. And then my inner product is negative 10. My outer product is negative 10. So that's negative 20x. And then I multiply the outer two and I get 100 equals 0. So I get negative x squared, right? Because x squared minus 2x squared is negative x squared plus 20x minus 3x squared, if I distribute the 3, plus 60x minus 300 equals 0. Simplifying, adding like terms, I get negative x squared minus 3x squared is negative 4x squared. And 20x plus 60x is 80x. And this is minus 300 equals 0. Now I'm going to factor out a negative 4. And I'm left with x squared plus 20x minus 4 goes into 300 75 times. Oh, well, this is going to be a plus, right? If I factor a negative out, let's factor out right. Equals 0. So let's see if that works. Negative 4x squared, and negative times a negative is a positive. Negative times a positive is a negative. So there we go. I've got it straightened out. Now, this factors, and I know that one of the zeros, since I know one of the places it intersects is at 5, right? So I know one of these factors has to be x minus 5. So this is going to be x, and then 5 goes into 75 15 times. So I'm going to say negative 5, negative 15. Now let's see if that works. The inner product is negative 5. The outer product is negative 15, which adds to negative 20. And then negative 5 times negative 5 is indeed positive 75. So my solutions are x equals 5 and y equals negative 15. Or I'm sorry, equals 15. So I know my one point where we intersect is at 5, 5. Well, that makes sense because, I know my y is equal to negative x plus 10, right? And if I plug 5 in, I get 5, 5, right? So what happens here? If I know, I'm sorry, why did I say y here? Oh my goodness gracious sakes, this is x. So if I say y equals negative x plus 10 such that x equals 15, that means my y value here is going to be negative 15 plus 10, which is negative 5. So my 2 points of intersection on this normal curve and the regular in the curve that we started out with here is going to be 5, 5, and 15, negative 5. Now I took the liberty of graphing this function or this relation here, and now I'm going to prove to you here that this is normal. Let's type the normal line. Y equals negative x plus 10, right? Get rid of this here. But negative x plus 10. And we can see clearly that it intersects in 2 points. And we suggested that it was 5, 5. Add a label. Well, that's true. And then 15, negative 5. It's what other point we solved. Okay, so the normal line cuts through this curve at 5, 5 and 15, negative 5. All right, so that's pretty cool, right? Right, well, we did this with algebra all by hand, but we could have done it on the calculator. And I'm going to show you how to do that really quickly here. So I'm going to F18, clear that out. Now, how do we take a derivative implicitly on the calculator? Well, we go to F3, which is our calculus menu, F3, and then we press the up arrow, which takes us to implicit differentiation, and we choose that, and we're going to implicitly take a derivative of this, which will be x to the second plus 2x times y, and you must use the multiplication in between the x and the y for this to work, okay? Because they're two variables. Minus 3y to the second equals 0, comma, independent variable, comma, dependent variable, close, and let's see if we get the same derivative. Do we? Well, mine was negative x minus y over x minus 3y. And sure enough, they have it in factored form in the numerator, but that's equivalent, certainly is equivalent. Good. Now, if I wanted to know what the slope was at 5, 5, there's a way to do this on the calculator. I'm going to grab my expression for the slope, and I'm going to use the such that bar here, the such that bar, and I'm going to say x equals 5. Now, if I want to tell it the y as well, I have to use an and here. So how do we find the and? We go second, math menu, and we're going to go to the test menu, which is 8, and we're going to choose number 8, and there's the and. Now you can type and if you want, but in order to do that, please note that there's a space here, and you'd have to use the space right here above the minus sign. So you go alpha space, and then you can go alpha A, alpha N, alpha D, and then you have to put another space afterwards. But when you use the second math menu test, and it puts the spaces in there automatically, which is nice. And then we're going to say y equals 5, and let's see, it tells us that the slope is 1. So nice, right? We got our slope is 1. Now we know that the normal slope is the opposite reciprocal, so that works, okay? Now, I know that I have to solve a system here, and I'm going to use substitution. Okay, so to use substitution, wherever in this equation here, wherever I see a y, I'm going to put this negative x minus 10, which gives me an equation full of x's. So I'm going to solve this equation for x. And how do we get to the solve? We hit the solve, the algebra menu, hit solve, which is number 1. And then we're going to type in our equation, which is up here. Let me remind you. Our equation was up here. X to the second plus 2x times y minus 3y to the second equals 0, right? That's the equation I'm going to solve, comma x. I'm going to solve it for x. And I'm going to close the parentheses, and I'm going to give it a such that, because I know that y, I'm going to say such that y equals this, which is our substitution. So I hit the such that bar, which is next to the 7, such that y equals negative x plus 10. So I'm giving it the substitution, and the calculator is going to solve for x. Now watch how quick this happens. I'm about to press it. Here it goes. I'm pressing it. That was pretty fast. Maybe 1 or 2 seconds, if 2 seconds. So our calculator says, well, the solution for x is 5 or 15. Isn't that what we got through this algebra that we did? Sure enough, it is. And that's pretty nifty that our 89 can find the implicit derivative, find the slope, giving it an x and a y, and it can solve a system if you have one of the equations solved for a variable, which I think is pretty nice. All right, so hopefully that helps you with number 26 from the 3-2 homework, and you have a great afternoon or evening. Thanks for listening.